Modern high-tech advances in medicine and health are of course the result of many centuries of development, research and experimentation, much of which took place in the Islamic world between the 9th and 14th centuries, a golden age of science. During this time, scholars in the Islamic world made huge contributions to medicine and created a body of knowledge that was tremendously important and influential around the world for many hundreds of years. I'm Jamal Khalili, a British professor of theoretical physics, but born in Baghdad. I'll be exploring state-of-the-art biomedical science and uncovering the contribution made to the field by the scholars of the Golden Age. It was during the Islamic Golden Age that medicine started to be treated as a true science, with emphasis on empirical evidence and repeatable procedures. During that time, medical books were written that became standard texts throughout the world for many hundreds of years. I've come here to the Hamad Hospital in Doha in Qatar to see how the ideas of the scholars from the medieval Islamic world compare to our modern medicine.
The hospital's neonatal unit deals with premature and newborn babies who are suffering from a variety of conditions. It's the only one of its kind in Qatar, and babies are referred here from across the country.
All in all, through our doors, we probably have close to 17 to 1,800 babies, and that amounts to about 10 to 11% of the total birth that occurs in this hospital. So it is, by comparison, one of the biggest units in the world. We do look after babies who are as small as 23 or 24 weeks gestation. So you're looking at a 5 months pregnancy, 5 months and 1 week pregnancy, basically.
And that in itself is incredible. I mean, not that long ago, 23, 24 week old gestation, there's no way they'd survive outside the womb.
Absolutely, and we've come a long way.
At this hospital, they're carrying out pioneering research to improve the treatment of babies born with neonatal encephalopathy. That is, babies born with serious neurological damage because of a problem with oxygen or blood supply in the womb.
The gold standard of treatment is putting these babies on a cooling mattress to try to reduce the temperature and limit the potential ongoing damage that could ensue in the brain. However, it does not really provide an appropriate success rate worldwide. Here we're trying a simple remedy that we believe has potential, which is the addition of a drug called magnesium sulfate. But it's never been tried in combination with the cooling method.
To improve the reliability of their research, the hospital's using what we call a control group. Some of the babies receive magnesium sulfate, whereas a separate group, the control group, don't receive it. This allows the hospital to compare fairly the effect of the treatment with and without the drug.
So this particular study is a double-blind placebo control, which means that we are offering some of our babies a placebo and some who are getting the magnesium sulfate. We don't really know which are which, and that's
Otherwise you might be biased
will be
towards,
biased,
yeah.
exactly.
One thing that's of tremendous interest to me is that this idea of a control group actually goes all the way back over 1,000 years to a Persian physician by the name of Al-Razi, who built the first hospitals in Baghdad, who was looking into the causes and treatments of meningitis. And I believe he had not only his sample of patients, but he had a control group to which he wasn't administering the treatment. In that case, it was bloodletting, which we know isn't the way you treat meningitis, but the idea of a control group goes all the way back to Al-Razi.
This is actually one of the most important components of research, that we do have a control group to try to ensure that our studies come out as non-biased as possible.
To compare against.
Yeah, absolutely, absolutely. Yeah.
Ar-Razi was born in the city of Ray near Tehran in the mid-9th century, and he was an early proponent of applying a rigorous scientific approach to medicine. During his distinguished career, he served as chief physician of hospitals in both Ray and Baghdad.
In the early 10th century, the ruling caliph in Baghdad, al-Muqtafi, asked Ar-Razi where in the city he should build a new hospital. So Ar-Razi designed an experiment. He hung meat up around different locations to see how quickly they rotted and so determine the place with the cleanest air. This was typical of Ar-Razi. You have a problem, you design an experiment to find the answer. During the Golden Age, the dissection of human bodies was considered disrespectful. But there was one group of people who knew quite a bit about anatomy, butchers, albeit the anatomy of animals rather than humans. Well, even though this is just a lamb's heart, not a human heart, we can still see quite clearly the different compartments, the different chambers within the heart. This would have been something very familiar to these early physicians of the medieval age. Shukran. In the 17th century, William Harvey famously carried out his groundbreaking research into the circulation of blood and the function of the heart. But in 1924, an ancient document was discovered. This was a text written by Ibn Nafis, a 13th century Arab physician. In it, he described the basics of pulmonary circulation, how blood doesn't move across from one side of the heart to the other, but has to take the long way round, around the body. This 400 years before Harvey.
Building on the writings of physicians like Ibn al-Nafis and William Harvey, our understanding of the heart has continued to develop. Harefield Hospital in the UK is part of the country's largest centre for heart and lung disease. Their cutting-edge treatments build on the work of Professor Magdi Yaqub, one of the world's leading heart specialists, who set up the hospital's busy transplant unit and who's received a knighthood in Britain for his services to medicine.
The heart is such like a magic organ. The more I learn about it, the more I respect it, because it goes on incessantly, beating quietly, maintaining life.
Professor Yaqub is also interested in the history of medicine. As part of a paper he commissioned for a medical journal, he's researched the life and work of Ibn al-Nafis.
Here we have a scholar born in Syria in the early part of the 13th century. He was a polymath because he was studying. He was a theologian, he was a scientist, if you like. He was a discoverer.
But arguably his most important contribution was his commentary on medicine, in which he looked at how blood moves through the heart.
So this is the heart, and you can see quite clearly the right ventricle and the left ventricle. And these are two completely separate chambers. The question has been, how does blood go from the right ventricle to the left ventricle?
For centuries, the accepted view had been that of the renowned Greek physician Galen. Galen said that blood passes directly between the right and left ventricles of the heart through tiny holes in the septum, the dividing wall that separates them. Ibn al-Nafis was the first to challenge Galen's view. He established that there weren't any holes, so there had to be another way for blood to pass from right to left.
The contention of some persons to say that this place is porous, it's based on the preconceived idea that the blood from the right ventricle had to pass through the porosity, and they are wrong. That's, he's quoted as saying that for somebody as young as this person at the time, when he was 29, to have the courage to state such a thing is absolutely remarkable. Galen said that there are holes in the septum, but If you open the right ventricle like I am doing now, it is solid. There are no channels whatsoever.
Ibn Nafis was absolutely right.
Ibn Nafis stated that the blood must first pass through the lungs, where he said it mingled with air before it came back to the heart and was pumped around the body.
Now we know that the blood from the right ventricle goes into the pulmonary artery, which is here, goes around the lung, comes back in these pulmonary veins into the left ventricle. So this is the pulmonary circulation.
Which comes here. That is the discovery. It's now obvious, but it wasn't then.
Ibn Nafis's description wasn't widely accepted at the time, and it wasn't until his manuscript was rediscovered in the 20th century that his work was universally recognized. It's now part of the long history of medicine that continues to evolve today.
We have learned a lot about the heart, and we have learned how to stop it, how to restart it, how to replace it, how to mend it. But my God, there's a lot more we do not know. The journey continues.
Early hospitals did exist in 8th and 9th century Baghdad, but these were little more than hostels for the sick, offering care but not much in the way of cure. However, hospitals as we'd recognise them today, giving treatment and offering medicine for free, did begin to appear around the empire in cities such as Cairo, Cordoba and Damascus.
In order for these hospitals to provide care, they needed a knowledge of medicines and surgery. The most important work of the Golden Age was written by the great 10th century philosopher and physician Ibn Sina, better known by his Latin name Avicenna.
This is my personal copy of his great text, the Canon of Medicine, Al-Qanun fi Tib. The full work was a multi-volume group of texts that took on where the Greeks left off, physicians like Galen and Hippocrates. In this first volume, he describes human anatomy in great detail. And what I love is that he talks about things like tashrih adl al-wajh, the muscles of the face, and then goes on to talk about the muscles of the forehead, the muscles of the eyeball, even the muscles of the eyelid. He then works his way through the entire human anatomy. In other texts, he describes surgery, he describes illnesses and their treatments. It's medical knowledge as they understood it then. It contained a lot of superstition, but a lot of common sense as well. The point is, this text was so important, it was still being used around the world over 500 years later.
Even though today we know that not everything Ibn Sina wrote was correct, his work was the pinnacle of medical knowledge at that time. In his canon, he includes a large number of medicines and remedies that use common herbs.
During the Golden Age, herbal remedies weren't an alternative to mainstream medicine. They were all they knew. And as the empire grew, travelers would bring back new plants from far and wide, so new drugs were discovered and administered.
Rima Hazmat is based in Ajloun in Jordan. She cultivates medicinal herbs, some of which have been in use since the Golden Age.
Lavender is good for relax for the body, and it's very good for antibacteria.
So even though they would have used this in the Golden Age,
Yes.
they wouldn't understand about bacteria,
Yeah, bacteria, yes.
but they knew it was still good.
This, yeah.
Okay.
And this is wormwood.
Wormwood.
Yes.
Ah, what is this used for?
It's good for the cold.
Oh, to treat cold
Yes,
symptoms.
Yes.
And this was known from a long time ago.
Yeah. This is sage. This can smell.
Sage. Oh, yeah.
Yeah, this is good for the stomach. It's good for cramp and constipation.
Aha.
Yes.
What I find so fascinating is that during the Golden Age, every hospital would have had a herb garden just like this. It was their drugstore. And it's interesting that we're hearing those same remedies are still described and in use in modern times. Shukran.
Thank you.
Ibn Sina's great Canon of Medicine describes a variety of herbs. 1,000 years after the canon was written, Dr. Detlef Quintern is growing some of these herbs in Gulhane Park in Istanbul. so that he can study the medical remedies that Ibn Sina described.
We planted, following the Canon of Medicine, 26 medicinal plants out of hundreds which had been described by Ibn Sina around 1020. He worked for 6 years on the Canon.
So these plants, they had medicinal properties. What sort of things would they have been used for?
They were antitoxic, anti-inflammatory.
And did they work?
Some of them are proven even today that they have this active ingredients, we say. I can show you one sample. It is called nowadays a Latin name, Nigella sativa. You can find it also on the bread, on the Turkish bread.
Oh, I see. Oh,
these are small black seeds.
Yeah, black cumin.
Black cumin, absolutely true, right.
And what would this have been used for? Do you know what properties it had?
It was also antitoxic. For example, Ibn Sina mentions it against bites, probably snake bites. It was used for anti-rheumatism, still it is used.
Like other important works during the Golden Age, Ibn Sina's Canon of Medicine spread across the Islamic world and beyond, as the process of knowledge transfer was revolutionized.
One reason knowledge spread so effectively throughout the Islamic Empire was because it suddenly became much easier to produce and copy texts. The Islamic scholars had adopted the Chinese technology of paper making, and paper is much cheaper to produce and use than parchment or papyrus. An important aspect of this was calligraphy, the art of handwriting. So I've come to meet a calligrapher to tell me all about it. أما الورق اللي كانوا يستعملوها مثلا العلماء في العصر الذهبي الإسلامي اللي كانوا يستعملوها بكتبهم.
نعم.
كان من أي نوع؟
هو ورق من ورق النباتي بشكل عام، يعني بشكل خاص، يعني ورق نباتي مأخوذ من الشجر ويعالج بالطرق الكيماوية حتى يصبح ورقا كما نصنع الآن الورق. ثم لما توسعت الدولة الأموية وصلت إلى حدود الصين، تعلموا صناعة الورق من الشجر، من طحين الشجر. فهذا انتشرت هذه الصناعة أيضا في كل أنحاء العالم الإسلامي وفي المدن الكبرى بشكل خاص، في بغداد ودمشق وحلب وسمرقند وبخارى، وانتشرت بشكل كبير جدا.
The Chinese paper was durable, lighter, and more easily bound into books, which created a thriving publishing and book copying industry. Manuscripts had to be duplicated by hand, and this produced a great demand for Islamic calligraphers.
هو هذا اللي شرحته بالإنجليزي. اللي يفتهم يقرأ عربي يشوفه هذه مو بس يعني خط واضح. هذا فن، هاي صورة.
لذلك يعني بزمانه حكى بيكاسو بيقول أقصى ما وصلت إليه في فن التجريد، أنا كنت فكرها مكذوبة الكلمة يعني، بعدين طلعت صحيحة.
صحيحة.
إيه، والأقصى ما وصلت إليه في فن التصوير كان الخط العربي قد سبقنا إليه بقرون.
Well, calligraphy clearly remains today just as important an art form as it was back in the Golden Age. The scholars then not only perfected the art of paper making, they also developed simpler forms of calligraphy, means of preserving their paper and binding glues to hold their books together. In that way, these technologies came together, enabling them to produce books in large quantities. This is how their knowledge propagated so effectively throughout the world.
The manuscripts of the Golden Age influenced scientists long after the decline of the Islamic Empire. For instance, Ibn Sina's Canon of Medicine was translated into Latin, and copies were still being printed and circulated well into the 16th century. These texts influenced the great thinkers of the Renaissance, who in turn laid the foundations for our modern world.
This impressive building is the Weill Cornell Medical College, an offshoot of Cornell University in New York, but based here in Qatar. I've come to find out more about their genetic research, how they're mapping the human genome to find out more about genetic and hereditary diseases pertaining to people in this part of the world.
The genome is the complex genetic code contained in every cell in our bodies. It determines all our inherited features, such as what we look like or what inherited diseases we might be vulnerable to. It's unique for every person.
So this is a microscope that allows you to look in different depth inside the cell.
Professor Khalid Machaka has great expectations of what sequencing genomes will reveal.
The program is about 6 years old now. The focus is on problems that are of importance in the region, particularly in Qatar, where there are a lot of families that have inherited diseases. And diabetes is a critical importance there, and neurogenetic disorders are critically important. So we've chosen to take those families and sequence both affected and unaffected members. And that will help us pinpoint the gene that causes a disease.
The key to understanding these diseases is to analyze people's genomes to look for differences. And to do this, they use a DNA sequencer connected to a supercomputer.
All living organisms are made up of cells. Each cell has a nucleus, and within the nucleus is the genetic material that defines the features that make us unique.
This genetic material is a code made up of over 3 billion components called bases. It's too long to be analyzed in one piece, so first they need to split it into smaller sections.
These machines does a process called shotgun sequencing. So essentially here what we do is take that genetic material, chop it up into small pieces, and load it into the instrument. It will interpret that information and put these pieces back together.
So rather than trying to follow the full string of the billions of bases on one DNA molecule, it's chopping it up, looking at different bits,
and then putting it back, piecing it back together.
Genetic technology is evolving rapidly. The lab has recently installed their most advanced piece of equipment for DNA sequencing. It's the first of its kind to be used in the Middle East.
This is the 3rd generation sequencer. And what it does is it sequences longer fragments of the genetic code. This one can give us, as you see here, the tail goes all the way to 40,000.
40,000
as opposed to 100 in that one. So that will give you more structural information on the chromosome.
This equipment makes it possible for the lab to sequence the genomes of large numbers of people. It's a huge advance since 1990, when the first projects to sequence the human genome officially began.
The original human genome, the reference, was sequenced in 10 years.
It was a huge international project,
it was huge.
wasn't it?
Yeah, it was a big accomplishment. Now we can sequence the human genome within 6 to 10 days with this technology. So the advances are huge within 10 years.
The work going on here puts the university at the forefront of modern research, building on the scholarly spirit of the Golden Age.
Where over 1,000 years ago, the flow was from the West to the Arab world, where people were coming to Baghdad and Alexandria and Damascus as centers of learning, and learning about the latest technology and what's going on, and then taking it back home and improving their own healthcare or mathematics or understanding of astronomy or whatever it is.
Do you feel personally a sense of pride that now in the Arab world and the Muslim world, there is this cutting-edge research going on again after so many centuries of decline, where it was once the center of knowledge and research?
Yeah, very much so, very much so. I think that's a huge incentive for a lot of scientists who are originally from the region to come back and contribute back. But I also see it as a bridge to, science tends to be a good subject to bring different people from all over the world together, because everybody's seeking new knowledge. So it's a great platform to kind of build connectivity and build a multicultural environment where everybody can discuss and talk about these things.
Well, my head is spinning. Not only are the laboratories here the most advanced and well-equipped that I've probably seen anywhere in the world, but they've brought together researchers from around the world, different cultures, different backgrounds, to work together collaboratively in a way that's so reminiscent of what happened in the House of Wisdom in Baghdad during the height of the Golden Age.
From astronomy and optics to chemistry and medicine, We've traced the journey of scientific discovery that links the scholars of the Golden Age to the cutting-edge science of our modern world.
What you have here is a handheld model of the sky.
Their achievements were groundbreaking.
This is a particular favourite of mine. It's beautiful.
And their discoveries still resonate today, almost 1,000 years after the Golden Age of science.